done this. What? I didn't see it. What'd he do? Anyway, here we go. So parabolas, okay? We're gonna start with the parent function for a parabola, and you've seen this. We've talked about parent functions. The parent function here is y equals x squared, okay?
Can I use a calculator?
Yes. Yep. We said that's a U-shaped curve. Okay, so you're going to have this U-shaped curve going on. Do you remember what the vertex is for the parent function? But what point? The vertex. 0, 0. So for the parent function, you're always starting at 0, 0. That would be right here in this graph. Okay. Your axis of symmetry for the parent function is going to be x equals 0. It's your y-axis. So this axis right here, that's your axis of symmetry. Okay. The domain for the parent function. So we're saying what x value can you plug in to this? Any thoughts? What could I plug in for x right now? Into y equals x squared.
I don't know what happens like that.
You can plug anything in, right? You could plug in a negative 1,000. You could plug in 2 million.
My sister played with it.
You could plug anything in. So your domain, your x values, are all real numbers. Now here's the thing, guys. That will never change. They're going to ask you for a domain for all of these. It's always all real numbers, okay? Easy points. Don't get that one wrong. The range, however, that will change. But for the parent function, what is your range? Where is y? What are your potential y values? Could y be a negative in that function? No. When you square something, it becomes positive, right? So y can't be negative. Could it be 0? No. Yes. Yeah, if you plugged in a 0 for x, 0 squared is 0, right? If you look at the graph, you can see it. Your y values just keep going up. Arrow means it keeps going, right? But it doesn't go anywhere below 0. So your range is y is going to be greater than or equal to 0. That's what all of your y values will be, 0 or greater, okay? And that one changes depending on the function. So it's not always going to be y is greater than or equal to 0. It is always going to be all real numbers for your domain, okay? Okay, vertex form. You've also seen this. So this is just the fancier version of it once we've shifted. Remember, left, right, up, down, all that shift stuff is happening. So can anyone tell me what your vertex is for this equation? Yeah, Casey.
Isn't it H and K?
Mm-hmm. It is H, K. Okay, so that's your vertex. What is your axis of symmetry? Do you remember? X equals H, yes. X equals whatever the x value is of your vertex. So x equals H for your axis of symmetry. Okay, so with this, you will either have what's called a minimum or a maximum. And let me show you what this looks like. Two different graphs. You could have something that looks like this, or you can have something that looks like this. This is called a minimum, okay? Because it's the low point of your graph. When you have an a value, remember your a is out here, okay? When that a value out in front is a positive number, something greater than 0, that will give you a minimum because your graph is going to open up, okay? So this is a minimum. If your graph opens up, you have a minimum. That means your a value is a positive number, okay? If your a value is less than 0, so if this is a negative a value, then you have what's called a maximum because the graph's going to open down. So your vertex is your highest point, and it opens down from there. So it's a maximum point for your vertex. Questions on that so far? I know this is just a lot of information. We'll apply it and it will make a lot more sense. Okay, last two things with A. If A is a number, technically we should say if the absolute value of A is greater than 1. If that's a number greater than 1, then your graph is going to do what we call a stretch. We kind of talked about this last chapter a little bit. A stretch is, this never makes sense to me, okay? I would do this the reverse way of what it actually is. A stretch, you have to think it stretches up. So a stretch makes it a narrower graph. Okay, whereas if your A value is a fraction, so 1/2 or 2/3 or 2/7, okay, if that A value is something between 0 and 1, then it's called a compression. And a compression is like push down on that and your arrows go out to the side. So a compression is going to make it a wider graph. Is that backwards to anybody else or is that just me? I think this feels more like a stretch and this feels like it got compressed.
Yeah.
But it could just be me too. Okay, so that's kind of all the like information. Now we're gonna apply it. We're gonna do some things with it. First of all, when we're graphing, there's two different ways to do this. The first way I'm gonna show you is if we use a table to graph it. Okay, and a table is just a t-chart, right? Your x values and your y values, you plug in a bunch of numbers. So if we're gonna graph this function, first of all, you should right away say, I know it's gonna be what shape? A U, because it's got that x squared with it, okay? But then what you're gonna do is you're gonna pick 5 numbers. And for these ones, we're always gonna pick the same 5. We're going to pick -2, -1, 0, 1, and 2. So when it tells you to make a table of values, make your table of values. If it says use shifting, then you're just going to use the shifting rules that we will talk about. Okay, so well, first of all, can anyone tell me what the vertex of this parabola is? 0, 0. We did not shift left or right. We did not shift up or down. This is just our A term that has changed. Okay, that's more about the slope than anything else. So 0, 0 is going to be my vertex. In other words, if I plug in a 0, f of 0, I should get 0 back. 1/2 times 0 squared is 0. Okay, so f of 0 is 0. So my vertex is 0, 0. Okay, then let's just plug in all the rest of those. F of -2 is going to be 1/2 times -2 squared. What happens when you square a negative? It's always positive. Don't forget that. If you square a negative, it's always positive. So -2 squared is 4. 4 times 1/2 is 2. So the point -2, 2 is on our graph. Okay, then plug in a -1. F of -1 is 1/2 times -1 squared. What does that equal? -1 squared is 1. What's half of 1? A half, right? You can call it 0.5. You can call it 1/2. I don't care. But -1.5 would put us right here. Okay, now here's the thing, guys. Technically, you should probably plug in the other 2 numbers, but also technically you should know where they go right now. Do you see it? We said this is going to be our axis of symmetry. So what if we just reflect it? That first point goes to here, that second point goes to here, and you would get this graph. I'm totally fine with you doing that. If you plug in a 1, you're going to get 0.5. If you plug in a 2, you're going to get 2. So they're just kind of reflections of each other. Questions on that? Okay, so then let's do this one. Let's just talk compression and stretch real quick. So if your absolute value of your A term is greater than 1, which if we took the absolute value of -3, that's a +3, should this be a skinnier graph or a wider graph? If you're looking up here, look at your A value, take the absolute value of it. Is that going to get skinny or wide? It's going to get skinny, right? When it's a bigger number, like 3, it's going to be skinny. The negative is just saying it's going to flip upside down, okay? So if we make a t-chart, x and y, you have -2, -1, 0, 1, and 2. Let's plug in 0 first. You may go just in order. You don't. I just like to find my vertex first. So -3 times 0 squared is 0. So when I plug in 0, I get 0 back. So 0, 0 is my vertex. Okay, now let's plug in a -2. So f of -2 is -3 times -2 squared. What does that equal? -2 squared is 4. 4 times -3 is -12. Okay, plug in f of -1. -3 times -1 squared is what? -3. Yep. So then plug in the positive. -3 times 1 squared is -3 again. -3 times 2 squared is -12 again, okay? This one goes way off the graph. If it goes off the graph, you don't have to plot all 5 points. Give me at least the first 3. So 0, 0, -1, -3, and 1, -3. So I'm just going to do those for now. It would technically keep going way further to the -12, but if you give me those 3, you're good. Okay. Here's the thing with parabolas, you guys. This number, this a term out in front, you can kind of treat it like a slope, but not exactly, okay? You have to take that number and put it over 1. So -3 over 1 is down 3. 1, 2, 3. To the right one and to the left one gives you your next point. But look here. If it's 1/2, we didn't go up 1 over 2, right? We went up a half over 1 to get here. So you still have to treat that as your top number of your slope and then put it over 1 if you're going to do that for your first move, okay? We'll talk more about that in a little bit, but just so you can see what we're doing. Any questions on that? I would say this is my least favorite way of graphing. I really like graphing them this way. This is shifting, and you don't have to do a bunch of calculations with this. You just have to say, I know where that would go. That would go up, it would go down, it would go left, it would go right, and then move it, okay? So we take our parent function, f of x equals x squared, and now they're subtracting 5. Do you remember inside versus outside? So if it's f of x equals x minus h squared, where is that moving? To the right, okay? When it's inside, so minus h or plus h would move to the left, right? So this scenario, you're moving left and right when it's inside the parentheses, okay? When it's like this, f of x equals x squared plus or minus your k value. Let's do that. I'm going to write plus or minus here because it could be either. If it's your k value outside of it, that's when we move up and down. So keep that in mind. That should not be new information. You've done this. But just to recap here. Okay, so look at this one. Where am I moving from my parent function? Down 5. So we're going to go 1, 2, 3, 4, 5 and put a vertex there. Okay, and then I want to see your next 2 points. And that all comes from this number. What number is your a value right now? It's a 1, right? Your a value here is a 1. So we're going to go up 1 over 1, up 1 over 1. Okay, so I want to see that for sure. To find one more set of points, so 2 more points so that we can get a good feel for what our graph would be, we're just going to plug a number in. And you need to decide what's a number that makes sense to plug in. Can anyone tell me what a good x value would be here? 2, right? We used a 1. 1 was here. -1 is here. 0 is here. So the next logical x value for you to plug in would be to plug in a 2. So if you take your x and your f of x, they're saying if we plug in a 2, Excuse me. So that's going to be 2 squared minus 5 is what? -1. So 2, -1 is another point, and then you can just reflect that. Flip it over to the other side too, and this is the basic shape of our graph. Okay. Oh, sorry, I almost forgot. Can anyone tell me the domain of this graph? All real numbers, every single time, right? You can plug anything in for x. What's the range of this graph? Y is what? Greater than or equal to -5. Y is greater than or equal to -5. Okay, domain and range. Okay, let's do another shift. Letter B. Where is this one moving? It's x plus 1 inside the parentheses. To the left, right? This is going to be left 1. So you're going to go from 0, 0, left 1. This will be your vertex. Okay, what's your A term right now? Remember, that's the number out in front. If there's nothing there, it's a 1. So you can go up 1 over 1 one time in each direction. Okay, but you can't do it again for the next one, or you're going to get a V, and this is not a V, it's a U. So then we need to plug a number in. And this, I feel like, is the part that gets tricky for some, is picking what number makes sense to plug in. What number, what x value could we plug in that makes sense right now? We already did 0 for our x, -1 for our x, -2 for our x. Go 1 to the left or 1 to the right? What number?
1.
You could do 2, but 2 is going to be further away. 1 would be your best bet, right? We want to put a point somewhere right here. So that would be plugging in a 1 for my x value. So if I plug in f of 1, I get 1 plus 1 squared. 2 squared is 4. So if I go 1, 1, 2, 3, 4, that would be my point. Okay? Your axis of symmetry is here. So if we just reflect it, that's 2 to the right. So just go 2 to the left. And now you have that U-shaped curve, like so. Naomi.
Do we need to put in the axis of symmetry?
Yeah, just go ahead and draw it in. I'm not super picky about it, but it is helpful just to see when you're graphing to see where you need to move. So I would put it in. How are we doing so far? What's your domain? All real numbers. What's your range? Y is not 0, but greater than or equal to 0, right? Because y can be anything 0 or above. So y is greater than or equal to 0 because it starts here and everything goes up from there, right? So y is greater than or equal to 0. You with me still? Is this making sense? Molly?
Yes.
So the 4 means to move up 4 from the x-axis? Like
Yes, because that's your y value, right? So if we plug in a 1 for x, our f of x, that's also our y, right? Y becomes 4. So 1 is our x, 4 is our y. Remember, f of x and y are the same thing, right?
Yeah.
So don't let that confuse you.
And then how do you know how to move over to once you went up 4?
Once I went up for, oh, so my axis of symmetry is here, right? I want them to be the same distance from my axis of symmetry. So 2 to the right means 2 to the left also, right? So it's just a reflection. You're just flipping over the axis of symmetry. Megan, I keep thinking your antlers are someone raising their hand. Every time I'm like, yeah, oh, just kidding. What do you call them? Are they not antlers? Horns, your horns, sorry. Antlers, my bad. Horns, your horns. Okay. Anyone watching this video is like, what the heck? Horns, antlers. Okay, letter C gets just a little bit fancier. Where are we going to plot our vertex? a positive 2. It's opposite of what it looks like inside, and the same as what it looks like outside. So we're going 2 to the right and 1 up. Okay. What's your A term right now? 1. There's this imaginary 1 here, so you can go up 1 over 1 and up 1 over 1. Okay. What's a good number to plug in for your next set of points? 0, right? Somewhere here. So at x is 0, if we plug that in, plug a 0 in here, we get g of 0 equals 0 minus 2 squared plus 1. So negative 2 squared is 4. 4 plus 1 means when x is 0, then y is 5. So that's the point 0, 5. 1, 2, 3, 4, 5. Okay, your axis of symmetry is right here. So if we're 2 to the left, go 2 to the right, and that will be another point on our graph. And then you would draw your U. Yes, ma'am.
Why is it g of x and not f of x?
That's just what they gave us in the problem. Yeah. Yeah, f of x, g of x, it's the same thing. It's just function notation instead of y. Okay, what's your domain? All real numbers. What's your range? Y is greater than or equal to 1, right? Your y value here is at 1. Everything's above that, so greater than or equal to. Okay, last one of these, and I would say we had enough, but this one's a little bit different. What's the shift, first of all? Where's your vertex going to go? Up 1.5. So up 1.5 is here. Okay, this is our axis of symmetry. What is your A term? Negative 1, which means this one opens down. So from that point, you're going to go down 1 to the right one and down 1 to the left one. So what's a good number to plug in? 2 or negative 2, either one. Positives are usually go over a little better. But be careful here, because think about what this is saying. It's saying the opposite of your x value squared. It's not saying negative 2 squared. It's saying the opposite, negative 2 squared. So you need to square first on this one. Plus 1.5. So this would be 4, but the opposite of 4 plus 1.5 is a negative 2.5. Okay, so when you plug in 2, so go over 2, you go down 2.5. Okay, if we reflect that, that's going to put us right here on the other side, and that will be our graph. Okay, now on the homework, you guys, if your 4th and 5th points fall off of the graph, then don't worry about it. Just give me the 3 points, okay? I like having the 5. And there will be times where I'll say you must give me 5 on a quiz or a test, but there will also be times where I'll say give me 3. So just, if it's going to fall off the graph, don't worry about the other 2, okay? Okay, questions on that? All right. Number 3. So now we have this function, and we're just going to name all the different pieces. So it's a very similar question with one extra little bonus piece here. We're going to find our Y-intercept, and I'm just going to graph 3 points on these ones, okay? What is your vertex for this graph? 4, positive 4, negative 2. Opposite of what it looks like inside, same as what it looks like outside. So negative 4, 2. Okay, so negative 4, 1, 2, 3, 4, 1, 2.
Isn't it 4 negative 2?
Yep, that's what I meant. This is just testing you guys. Sorry. 4 negative 2, my bad. Same as what it looks like. Opposite, I said it right? I said opposite of what it looks like inside. Same as what it is outside. I just wrote it wrong. So 4 negative 2, yes, is what I want. 1, 2, 3, 4, 1, 2. That's better. What's your axis of symmetry?
X equals 4.
X equals the h value. X equals 4. Don't forget the x equals. Don't forget it. Okay, so to graph the extra points, where do you move with a 3? Treat it like a slope, right?
Up 3.
Up 3, 1, 2, 3 over 1, up 3 over 1, okay? I'm just going to graph those three for now. So your graph is going to look like this. What is your minimum? What is the y value's lowest point? -2. Your minimum will always be the y value of your vertex. So -2, right? Same as this right here. What's the domain? All real numbers. What's the range? Yeah. And this one, the range, will always be that number right here also. Okay? Okay, here's the new one. How do you find the y-intercept? There is a y-intercept. You could rearrange it into y equals, no, you couldn't. You couldn't because it's a quadratic. So that's a good thought, but no, you couldn't actually do that. Not point slope. Think about a y-intercept. One of your values never changes. Not -2. If I'm going to find a y-intercept, what's my x value?
0.
0 every time, okay? For a y-intercept, all you're doing is you're plugging in 0 for your x, right? Because a y-intercept always has an x value of 0. So if we do that, we say y equals 3 times 0 minus 4 squared minus 2. -4 squared is 16. 3 times 16 is 48. 48 minus 2 makes our y 46. So my y-intercept is 0, 46. Please don't try to plot that. It's way off the grid, okay? But that would be your y-intercept. Questions on that? Yeah.
With 46, we could try y.
Don't write y equals 46 because that sounds like you're naming a horizontal line. If you just told me 46, I probably wouldn't mark that wrong. Okay, you try this one. Find the vertex, the axis of symmetry, graph 2 more points. You don't need all 5 points, just graph 2 more. Is that a hand? Yes.
So is it always like y is bigger than unless the,
Or less than if it opens down.
okay.
Yeah. Less than or equal to, sorry, not less than. It'll always have the equal to. I don't know how people wear hats all the time. They're so annoying. I hate them.
I'm sure you can get a haircut.
If your hair is cut, it's more comfortable. I need to shave my head.
No, I just was saying that because I'm wearing it.
Oh, gotcha. I'm wearing it because I love the Dodgers, but I'm getting a headache. Okay, what did you get for a vertex? -3, 4. What'd you get for an axis of symmetry? X equals -3. So let's plot that. -3, 1, 2, 3, 4 is here. Axis of symmetry is here. I forgot to put my axis of symmetry in over here. Sorry. So extra points. Where are we going to move? Down 2. Yep, down 2 to the right one, down 2 to the left one, and then that can be your graph. You can just draw that in. What's your maximum? 4. It's always this number. It's always the y of the vertex is your maximum or minimum. What's your domain? All real numbers. What's your range? Less than or equal to 4. If it opens down, right, your y value is going down, so less than or equal to. What's your y-intercept?
0,
Negative 14, yeah, it's 0, negative 14. If you plug a 0 in, y equals negative 2 times 0 plus 3 squared plus 4. So 9, negative 2 times 9 plus 4 is negative 18 plus 4, which is a negative 14. Questions on that? Right along. So here's the deal. 4.1b, the second part of this, normally we do these on 2 different days. So these first 2 questions are like, let's review what we did yesterday and make sure we're good. So I'm not going to do those 2 right now. I'll do them at the end if you want 2 more, okay? But for those of you that don't need those extra 2, I'm going to let you get started on the homework if you want to. So we're going to go to number 3 right now. And number 3, it says write the equation of each parabola in vertex form, okay? We know vertex form. Remember, vertex form is this. Y equals a times x minus h squared plus k, okay? I'm going to show this to you as a 3-step problem. If you do the first step for me on the test, but get everything else wrong, I will still give you some credit for that. So if you want to break it down into the 3 steps, that's fine. You don't have to do the 3 steps that I'm going to show you. Some of you are going to be like, I don't need that. Like, I can just lay it all out and I've got it and I'm good. That's fine. I don't care if you do it that way. Just know that the partial credit comes in if you can set part of it up correctly. So if you make a mistake, it might be worth your time to do the 3-step way, but it's up to you. I really just need the final answer to be the right final answer for full credit. So here's what we're doing. You are given a vertex, and I highly, highly recommend that you label that H and K so that you don't mix them up, because when you mix them up, the whole answer is wrong. Your other point is your X and your Y. Okay, so we have this equation. We want numbers plugged in to 3 places, here, here, and here, okay? You're gonna have a Y in your final answer, you're gonna have an X in your final answer, but every other letter should be a number by the time you're done, okay? Okay, so the first step that I always tell people, here's your safe first step if you want to go that route, is just plug in H and K into that. So Y equals A times X minus 3 squared plus 2. Do y'all see where I'm getting that? Just plugging in H and K.
Wouldn't it be x plus 3?
No, because the basic form is minus here and plus here. So it's x minus whatever your h value is. And your h value is 3, so it's x minus 3.
Oh, never mind.
Right?
So it would be positive to negative.
If it's a negative, you would do x minus a negative, which is x plus. Yeah. Okay, second step then. Now plug in the x and the y. So now we're going to plug in these numbers in place of x and y. So it's going to be 5 equals a times 1 minus 3 squared plus 2. Okay, so the whole idea here is figure out what a is. In order to do that, you need to think through some PEMDAS stuff. So 1 minus 3 is a negative 2, and negative 2 squared is 4. So that whole piece equals 4, but look at what it's doing. It's a times 4. A nicer way to write a times 4 is 4a, right? So we have 5 equals 4a plus 2. So we're going to take away the 2. So 3 equals 4a, and then divide by 4. So my a value is 3/4. Okay, now the reason I say do that first step is because all you have to do right now, if you do that first step, is take this a and drop it in right here. Okay, so you go back to that first step and you say y equals 3/4 times x minus 3 squared plus 2. And that is your answer. Okay, but like I said, I don't have to see this from you. I just think it makes people's brains go in the right place if you do it that way. And it makes that last A plug-in very simple. Okay?
So you don't have to solve y equals, we don't solve that?
There's nothing to solve here. It's just asking for the equation of the parabola. So that's the equation of your parabola.
So you wouldn't plug in the x and the y in the final answer?
No, because we plugged in the x and y to find our a, but we want to know, because you can plug in any point to this, right? You could plug in a 6 for x and then figure out what your y would be. You could plug in a 2 for x and see what your y would be. So if you plotted those, sure, it would give you points on the parabola, but we want the whole parabola. So we don't want to specify an x and a y right now because we want the whole thing. That makes sense? Okay, do you want to try the second one by yourself doing that or do it together? Okay, try it on your own real fast and then we'll do it together. First of all, your vertex you're going to label as what? H and K, the other point as your x and your y. All right, give it a go. And if you finish that one and you want to try the graph, you can help yourself to that one too. Who's got an answer? Who wants to give me an answer? What'd you get?
Y equals 2.75.
Why? That's not funny. Why is that funny?
I'm good.
Yeah. See what you just did?
I'll
Rude. What'd you get for A?
Y equals negative 5 over 4. And then parentheses x minus 2 the second minus 3.
Yes, so negative 5 over 4. So start with that first. Y equals A times x minus h squared plus a negative 3, so minus 3. Okay, that's your like step one. Here's the basic setup. Then we plug in the x and the y. So if you plug in negative 8 for y, a times 4 minus 2 squared minus 3. 4 minus 2 is 2. 2 squared is 4. So we get 4a minus 3 on the right, negative 8 on the left. So add 3. So negative 5 equals 4a, and then divide by 4. Okay, so a is negative 5 over 4, and then you just take that a, this negative 5 over 4 gets dropped into that very first equation that we wrote right here. So it's going to be y equals negative 5/4 times x minus 2 squared minus 3. Good? Okay, last one, if for those of you that want to be done. I will do the other two at the beginning if you want to see those two. But how do we do this one? They give us a graph. Same problem, but different given. What? Find the vertex, not a slope. We're not going to find a slope because we don't technically have slope with a parabola. What's your vertex? 3, 1. Okay, so our vertex is 3, 1. What else do we need? What have we been doing in the last two? We don't need AOS here. We just need a point. Where is there a point?
0, 7.
You could do 0, 7. That's the one I would do. Or you could do 6, 7 would be fine. I would do 0, 7 because I like zeros. So if we plug this in, this is H and K. This is X and Y. It's the exact same problem from here now. So it's going to be Y equals A times X minus 3 squared plus 1. Then plug in our X and our Y. So 7 equals A times 0 minus 3 squared plus 1. And then simplify that. Negative 3 squared is 9. So 9A plus 1 equals 7. Take away the 1. So 6 equals 9A. And then divide by 9. So A is what? 2/3. A is 2/3. So you take that 2/3 and you drop it into your very first equation. Y equals 2/3 times X minus 3 squared plus 1. Questions on that? Okay, if you feel good and you don't need the extra 2 problems that we skipped, you are welcome to start on the homework. If you want to do 2 more with me, I'm going to do those 2 problems up at the top of 4.1a. You're welcome to follow along with me if you are interested. Okay, what is your vertex? Is anyone doing these with me? Okay, what's your vertex?
So 1 and 3.
A positive 1 and a positive 3, right? Opposite of what it looks like, same on the outside. Is your phone there? Yeah. So 1, 3 is your vertex. 1, 1, 2, 3. Okay. What's your axis of symmetry? It's not 1. 1's the number. How do you write an axis of symmetry? X equals. So X equals 1 is your axis of symmetry. It's always this number, but X equals. We'll put that in. Here's your axis of symmetry. What's your Y-intercept on this one? What do you do to find your Y-intercept? Plug in 0, right? We're just doing it in a slightly different order. So Y equals negative 2 times 0 minus 1 squared plus 3. So negative 1 squared is 1. Negative 2 times 1 is negative 2 plus 3. So Y is 1 for that. So your Y-intercept is 0, 1. So plot that and reflect it, and that will give you your graph. Okay. The other way you could have found those 2 points is just using your A, right? You could have gone down 2 to the right one and down 2 to the left one, and that would have gotten you there too. Yes. Is your phone? Yep. Leave that there. What's your maximum? 3. Yep. Your maximum is always your Y value of your vertex. What's your domain? All real numbers every single time. Free point. Please take it. What's your range? Uh-oh. My pen stopped working. What's your range? Less than or equal to, because it's opening down, right? So the highest Y value is right. Oh, come on. We've been doing so good. Don't fail me now. So this will be Y is less than or equal to that Y value, which is 3, which is always your maximum number or your vertex Y value. Okay, it's always going to be whatever that number is. Let's try one more time here. Hey, look at that. Y is less than or equal to 3 will be your range, and then you're done. Questions on that one? Okay, second one. What is your vertex? Negative 2, negative 1 is your vertex. So negative 2, negative 1, that would be right here. Axis of symmetry? x equals -2. So that's here. Okay, y-intercept. Plug in 0. So if you plug in a 0 here, 2 times 0 plus 2 squared minus 1, that's 2 squared, so 4 times 2 is 8 minus 1, so 7. So 0, 7 is your y-intercept. If it fits, you can graph that. 1, 2, 3, 4, 5, 6, 7. That would be about there. So feel free to do that and reflect it if you want. What is your second point from your vertex going to be? Where do you move? What does that 2 do for us? Up 2 over 1. Yep, so from the vertex, up 2 over 1 and up 2 over 1. So this is your graph. Okay, what's your minimum? Not -2. What's the low point of your graph for your y value? Not 0. Where are we at? -1. It's always your vertex y value. So your minimum is -1. What's the domain? 3 points. All real numbers. What's your range? Y is less than, greater than? Greater than or equal to what? The -1. So these 3, you guys, are always the same. Vertex, minimum, range. All the same number. Okay? All right.